Consider this given problem statement. So in a class of 140 students numbered from 1 to 140, all even numbered students opted mathematics course. Those whose number is divisible by 3 opted physics course, and those whose number is divisible by 5 opted for chemistry course. So then the number of students who did not opt for any of the three courses is what? So that is what the demand of problem statement is. So I'll just use some notation that is not standard, maybe just to write the language in a concise manner. That's it. So let us say this n number of elements in set M, where M represents the number of students, the even numbered students opted for mathematics course. So for this one, I'll represent them by 2n. And this we can get it by the floor division, of total student by 2. So if I perform the floor division, that is 70. In the similar manner, I can compute for the number of students for physics. So P represents the set of physics. So the students whose number is divisible by 3. Okay, so I'll represent for this one as 3n. So for this 3, we can write 140 divided by 3. So if I perform floor division, that would result in 46. Next, the number of students, who opted for chemistry. So let's represent them by 5n because of multiple of 5. So this one can be written as 140 floor division 5, and this will result in 28, right? So we have this data. Now we need to figure out all those students, who have not opted for any of the three courses. That means I have to take union of all these three sets, and the union number is given to us. So we need to figure out those students who have not opted for any of this. So 140 is the total, and we need to figure out the number of students for M union P union C. Once we get this number, so from the total we can subtract this particular number, right? So let's compute the result for M intersection P. So let me write here number of elements present in for both mathematics and physics. So and means intersection, right? Intersection, mathematics and physics. So this one I can represent them as 2 times 3, that is 6n. So this can be written as 140 floor division with 2 times 3. 2 times 3, that is 6. And this will result in 23. In the similar manner, we can do the same thing for physics and chemistry as well. Physics and chemistry. So this would be, so for chemistry we have 5, and for physics we have 3. So this would be 5 times 3, that is 15. So 140 floor division with 15. So this will result in 9. Next, the same thing we'll do for both of the combination, that is chemistry and mathematics. Now I'll do it for chemistry and mathematics. So for this I can write 2 times 5. 2 times 5, that is 10. So here I can write 2 times 5. So 140 by 10, that is nothing but 14, right? And finally, for all of those three, that is number of elements present in M intersection P intersection C, right? M intersection P intersection C. So this will be nothing but, this will be 2 times 3 times 5, and this is just the notation. And to get this number, I can take this, and whatever this number is there, that is 2 times 3, that is 6, and 6 times 5, that is 30, right? So 140 floor division with 30, that will be 4. And now it is a well-known fact for us, that is the number of elements present in M union P union C. This will be equal to number of elements in the set of mathematics, number of elements in P, then number of elements in C. So this is the inclusion and exclusion principle, right? Minus number of elements present in M intersection P, then remove this part as well. Number of elements in C intersection P, and maybe this would be a better option if I can write this in the next line actually, right? So I'll just write this in the next line. Yes. and then minus number of elements in, that is, C intersection M. And finally, after removing this, so first of all I have included this. Now at last I need to add the intersection of these three sets, right? So in this case, just to make little bit of space here, so this is equal to this, and finally I will just add this number of elements present in, that is the intersection of all these three, right? Yes, I'll just write it. Okay, and now I'll arrange it little so that it is easy for us to understand. Okay, now in the next line, so the number of elements present in M, so this is for M we have computed, that is 70 plus, so 70 plus 46 plus, next one was 28, 28 minus, this was for 23 plus 9 plus 14 and plus 4. If I just plug in the values now, so this comes out to be, if I calculate this, this is 102. So this is nothing but 102. Now we are having the number of elements present in M union P union C. So we can say that the number of students who did not opt for any of the three courses, So in the universal set, we had total 140, right? In the problem statement, it is given. In the universal set, it is 140. So 140 minus this computed number, that is the number of elements present in M union P union C. That would be 140 minus 102. That is nothing but 38. So 38 is the answer for this problem statement. So there are 38 such students. There are 38 such students who did not opt for any of the three courses, right? So I hope it is clear to everyone.